If you're anything like me, you've probably dabbled with the idea of boarding a rocket and leaving this hellhole of a planet behind you to go live on Mars or somewhere equally isolated. But how does a rocket actually work? It all comes down to a little something called the conservation of momentum. If you take any group of things and add up all of their momentum, that number cannot change, so if one of those things gains momentum, the others have to lose it. But Martin, I hear you cry, what is momentum? To which I reply, how do you know my name? Why can I hear you? Are you in my house? And please get out. If you take how heavy something is and multiply that by how fast it's going, you get its momentum. Now, unless you live in a hole, you probably know that a rocket works by farting out fire. If we consider the rocket and its fuel as our system, then to make the rocket increase its speed, we need to increase its momentum. To increase its momentum, we need to decrease the momentum of the fuel, or increase the fuel's momentum in the opposite direction. But rockets are heavy, which means we need a big change in momentum to get it moving even just a little bit, so we shoot the fuel out as fast as we can to get the biggest possible change in momentum. How? By turning the fuel into an explosion, that trail of fire you see behind the rocket. Now, this may be sufficient for a small rocket, for example, in order of destructive power, a firework, a missile, or a bottle rocket, but for big-ass rockets like the Saturn V, which, if you believe mainstream media, took people to the moon and back, you also have to consider the weight of the fuel itself. When the rocket sits on the launch pad, it's full of fuel, which makes the whole rocket heavier, so you need more fuel, which makes it heavier, and so on. One way of mitigating this effect is by splitting the rocket into stages. Once the rocket's already moving and you've used up a bunch of fuel, you can ditch the bottom part of the rocket with its empty fuel tank and decrease the total mass, making the rest of the rocket more efficient. Now, as you might expect, building one of these things and making sure that the continuous explosions go off at the right time and in the right direction without destroying the whole thing is quite a challenge. After all, it is rocket science. Nevertheless, engineers are getting better at it all the time as technological advances are made. Sadly, interplanetary rockets are expensive, and by the time they become cheap enough for a YouTuber to own, Mars will probably be full of people anyway, so I guess I'll just have to live in my bedroom like everyone else. If you enjoyed watching this video, you could consider doing this, or this, or this, or this. These will boost my self-esteem, which will in turn entice me to make more things like this.